Let us briefly talk about something closely related to metric precision, the concept of measurement scales. This concept comes from number theory, but don't worry, we are going to keep it brief and hopefully very interesting. There are 4 types of measurement scales and they follow an increasing level of precision. First, we have the nominal scales. These are just labels or categories. There is no ordering or comparison possible between the nominal scales. Think of vulnerability types. Saying, for instance, that SQL injection is worse or better than XSS doesn't make any sense at all in this world. Just like in the real world, actually. Next, we have ordinal scale. Here, the data has order, but the intervals aren't meaningful. This is where risk and severity levels like low, medium, high, critical are categorized or used. You can rank them, but doing math with them is nonsense. There is no analysis possible with those. 1 high does not equal 10 mediums, just doesn't hold up. Then we get into interval and ratio scales. These are very precise. The key difference between them is that ratio scales has an absolute 0. So things like time, cost, or effort fall into this category. Here is the key takeaway. Scales determine what type of analysis is valid, and using the wrong type of math on the wrong scale leads to bad conclusions. For instance, trying to calculate the total organizational risk by adding up weighted low, medium, high findings, that's based on ordinal data and it's just wrong. Remember that book on risk quantification I mentioned earlier? One of its key ideas is exactly what we've been building up to. Stop using ordinal scales like low, medium, and high and start expressing risk in dollar value using ratio scales. The book makes a compelling case. Estimating risk in dollars may seem harder, but the worst case effort is about the same as coming up with low, medium, high label. Even if your metric has perfect precision and consistency, there are 3 types of validity threats when it comes to jumping from your metric values to answers and conclusions for your questions and goals respectively. Content validity is about how much of the outcome does your metric cover. So if you're trying to answer the question, what is the security awareness of your employees? Metric 1 in this case measures the number of training sessions. Assuming you have learning management system, this metric has pretty good precision and consistency. However, your question is to ensure security awareness and the number of training sessions does not reflect on that in any way. Metric 2 measures how much of the top security risks are covered in the training materials. This metric has a much better content validity. The second validity threat is referred to as criterion validity. It looks into how well the metric correlates with the outcome. Let's take the same question that we had on the previous slide. What is the security awareness of our employees? Metric 1 is about how much of the top security risks is seen throughout the training material. However, a higher coverage doesn't necessarily correlate with better awareness. To improve the correlation with the outcome, metric 2 is doing a better job as it measures the percentage of top security risks understood after the training. For instance, by using a quiz, you could check that. Metric 3 is even better as it makes sure that the knowledge is retained. So metric 3 checks the percentage of top security risks knowledge retained throughout the year. Finally, construct validity is about how well the metric reflects on the concepts we are trying to measure. If your question is how prepared your employees are in case of an actual cybersecurity attack scenario, metric 1 would be to check how well everyone reacts to attack simulations based on the training material. However, we're actually trying to measure how well your employees will react in case of an actual attack that might or might not be based on something they have seen throughout the training. It could be that this is a variant, for instance. So metric 2 has a much better construct validity as it's about real-life attacks, whether or not seen on a training. Let's talk about some common pitfalls when you start combining metrics. The first one is what we call hidden redundancy. You might be tracking two metrics that are really measuring the same underlying thing. For instance, firewall hit count and intrusion detection system alerts. Which means both might spike from the exact same event, and if you treat them as separate signals, you're essentially double counting the same risk. The second pitfall is using two metrics that have a common component. Some metrics share a common denominator, which make them misleading, especially when you try to correlate them. For instance, if you have time to detect and mean time to repair, the second metric, mean time to repair, actually includes detection time. So if the mean time to repair goes down, it could be that your detection got faster, but the actual repairs didn't speed up at all. The final pitfall is called exposure factors in metric science. In the SAMM model, we call it environment metrics. In essence, exposure factors are about recognizing the context or environment your metrics live in. Let's look at an example. Say system A has 50 vulnerabilities and system B has 100 vulnerabilities. The question could be which system is more secure. While system A has less vulnerabilities than system B, we could assume that more lines of code means more complexity and more size. And when we look at it from the size perspective, per line of code, we have less vulnerabilities in system B. Now, while this example helps me illustrate the exposure factor idea and pitfall, at this point, you should also remember the rest of the concepts that we've talked about this course and object strongly to this silly comparison, because number of vulnerabilities say nothing about the risk. So you cannot really conclude based on 100 vulnerabilities versus 50 vulnerabilities that system B is more secure or less secure.